Welcome back, Algebra 1. We are continuing with quadratic functions this week, and this is going to be the last method we use to solve. I'm going to be honest, we're not covering every single method that you can use to solve just because of the situation we're in, but we're covering the most important ones. So this last one is solving a quadratic function using the quadratic formula. Okay, so let's just kind of get into reviewing our first part, quadratic roots. The solutions, remember, roots and solutions are the same word, essentially. They're synonyms. So the solutions to a quadratic function are the point or points where the parabola crosses the x-axis. The solutions, also known as, so what are my three words? I want you guys to think about what are those three words that are the same as solutions. One is already given to you on the notes here. So you should be thinking about those that are also known as roots. They're the same as x-intercepts and zeros. So all of those words mean the same thing. Solutions, roots, x-intercepts, zeros are all synonyms. So the solutions are the x values when y equals 0. Okay, so we've kind of talked a little bit about this, but we haven't seen it on a graph. So there are different types of solutions. You can have two solutions, one solution, or no solutions. You guys have seen it where there's no solutions. We talked about that in the last video with square roots. Most of the time you've seen it with two solutions. I don't know if we've talked about one solution yet, but we're going to talk about that today. So when I have two solutions, that's typically your most common one. That's when you guys have a parabola that looks, it doesn't have to look exactly like this, but it looks something like this. It crosses the x-axis at 2 points. And so those are my two solutions. Now with one solution is different. One solution looks like something like this. It could be facing down, and it could look like this. So this is something that has one solution. Now, when it has one solution, what is this point also known as? That point is also known as the vertex. So the vertex will be the solution when there is only one solution. So the vertex will be the solution when there is only one solution. So the vertex and the solution are at the same exact spots when it's one solution. And then no solution is like something we saw yesterday or whenever you guys watched the videos, but in the last video. So no solution is when the parabola is either above the x-axis and it never crosses it, or it could be below the x-axis and it never crosses it. So it's basically just saying it never crosses the x-axis. So those are your three types of solutions that you could see. It could have 2, 1, or none. So that's what kind of we're always solving for. Does it have two solutions? Does it have one solution? Or does it have no solutions? Okay, so solving quadratic functions using the quadratic formula. So when a quadratic function cannot be factored, you can use the quadratic formula to find the solutions. Now, what's super important with the quadratic formula can be used to solve any quadratic, even when it's not factorable. I prefer factoring However, if you just want to like know one method and that's it, you can solve any quadratic, the quadratics that we solved in the prior video, the one that we did last week. If it could be factored, if it could be solved using square roots, we can always use the quadratic formula. Okay, so let's talk about the quadratic function in standard form. So that's going to be y equals, I'm going to get my colors here, ax squared plus bx plus c. So the quadratic function needs to be in standard form for us to be able to use the quadratic formula. So the quadratic formula, and in normal situations, I would say you need to have this memorized. And we would do things where you would memorize it and you'd say it and you'd have it memorized. In your other classes, you will need to have it memorized. So the quadratic formula, and we'll talk about different like tricks so you can memorize it, is x equals, because we're solving for x, the opposite of b plus or minus the square root of b. I'm going to put b in parentheses because I always want you guys to remember when we're squaring something, it's in parentheses. So b squared minus 4 times a times c. And if you need to put like a little, multiplication symbols there, that's fine. And then it's all over. So everything, the square root, the negative b, everything is all over 2 times a. Okay, now I realize that this is going to be like a butchering of my, singing voice. But one way to remember this, I think it's with Pop Goes the Weasel. Wait. Yeah, Pop Goes the Weasel. So the way, and like a sing-songy way to do it with Pop Goes the Weasel, it's like Pop Goes the Weasel. It would be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So again, I'll sing it for you one more time. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's one way to memorize it. Another way to memorize it is there's a story. So the negative boy couldn't make up his mind, that's the plus or minus, if he wanted to go to a radical house party. But the boy was so square that he missed out on 4 awesome chicks, and the party was all over at 2 a.m. So the negative boy couldn't make up his mind if he wanted to go to a radical house party, but the boy was so square that he missed out on 4 awesome chicks, and the party was all over at 2 a.m. There you go. There are your 2 ways that help you to memorize the quadratic formula. But again, like I said, it's super important. It's going to be something you deal with in geometry. You deal with it in algebra 2, pre-calc. So all of your math classes going forward. So before you can plug A, B, and C into the quadratic formula, the equation must be equal to 0, just like we've been doing, and written in standard form. Okay, so let's get into our examples. So our first example says 6x squared plus 5x equals 4. Now, your first thing that you always want to do is you want to first make sure the equation is set equal to 0. And so we have to move this 4 to the other side of the equation. So it's a positive 4, so I'm going to subtract 4. Now this 4 can't combine with anything. 6x squared is not a like term with 4, and 5x is not a like term. So I'm just going to write it in standard form. 6x squared plus 5x minus 4 equals 0. Then once I get that going, now I'm going to identify A, B, and C. Okay, so let's look at here and think first, what's my A value? So the A value is always attached to the x squared. So A here is 6. So it's the one that's attached to the x squared. Always, always, always. So even if it's not in standard form, you can always tell what A is. B is the number that's attached to x. So B here is 5. So again, B is the one that's always attached to the x. You always bring the sign with it. And then C is the number that's by itself. So C here is -4. And so it's the number that's always by itself. So now once you've identified A, B, and C, you can just plug into the quadratic formula and simplify. So I'm going to do this part by part. I really recommend you guys get a calculator for this because it's going to really help you. So let's get into that. So x is going to be equal to the opposite of b plus or minus the square root of b squared, so 5. I'm going to put it in parentheses. Squared minus 4a, which is 6. We're multiplying, so I'm putting parentheses around it. A times c, again, we're multiplying, so I'm putting parentheses around it. All divided by, so notice how the fraction goes all the way over everything to a. Okay. So I always start by simplifying the inside first. So I simplify the 5 squared, and I simplify the 4 times 6 times -4. So I'm just going to rewrite everything else. So I have -5 plus or minus, and I think, okay, 5 squared is 25, minus, and then 4 times 6 times -4 is -96. All divided by 2 times 6. I can simplify that too. 2 times 6 is 12. Okay, first thing I recognize here, a minus and a minus becomes a plus. And so then I can simplify that. 25 plus 96 gets me 121. Well, at this point, do I know what the square root of 121 is? And I do. I know that the square root of 121 is 11. And then I think, can I simplify this further? And I can. And so I actually split it up into 2 different solutions. And I'm going to move that over here. So it's going to be x is equal to -5 plus 11 over 12. And then x is equal to -5 minus 11 over 12. So -5 plus 11 gets me 6. And 6 over 12 gets me 1/2 when we reduce that. And then -5 minus 11 gets me -16. -16 over 12, again, we can reduce that by dividing everything by 4. That's -4 and 3. So x is equal to -4/3. So I have my 2 solutions. And so I'm just going to write them as x equals 1/2 and -4/3. Now, this quadratic is actually factorable. And I'm going to show you how you could get to the same point by factoring. And I wanted to show you kind of both ways. So if I have, factoring would be the same thing. 6x squared plus 5x minus 4 equals 0. We'd want to always set, with factoring too, just like the quadratic formula, we want to set it equal to 0, and then I would factor. So I'm thinking 6 times negative 4 is negative 24. What multiplies together to get me negative 24, but adds to get me 5? And that's 8 and negative 3. So 6x squared, I'm going to put the 3 with 6 and the 8 with 4. And then I can factor by grouping. So I just split my middle term. I'm factoring by grouping. What can I factor out of 6x squared and 3x? And that's 3x. And I'm left with 2x minus 1. What can I factor out of 8x and 4? And that's 4. And I'm left with 2x minus 1. And then I can write it factored. 3x plus 4 and 2x minus 1. With factoring, once it's completely factored, we can set each factor equal to 0 and solve for x. So subtract 4, divide by 3, and I get negative 4/3. Add 1, divide by 2, and I get 1/2. And so those solutions are the exact same solutions I got here. So this one was actually factorable. So like I was saying up above, the quadratic formula can be used to solve any quadratic. We have to use it when something isn't factorable, but we can use it at any point. So it's kind of like whatever you feel most comfortable with. I feel more comfortable with factoring. So if I saw this, I'd always first think, can I factor it? And I know I could, so I would. But if you can't, then you have to use the quadratic formula. So both methods, I just wanted to kind of give you guys that exposure so you could see both. Okay, so let's look at 2. Number 2, I want you guys to think about what would be your first step in solving this problem. So what's my first step that I would do first? And if you thought move that negative 24 over, you would be correct. We want to add 24 to both sides. 24 can't combine with anything, so I have x squared minus 10x plus 24 equals 0. Okay, now what I want you guys to do, I want you to pause me here. I want you guys to think about what's your A, what's your B, and what's your C. So pause, think about what's A, what's B, and what's C. So A is a little bit challenging because there's no number here. What number can we always assume is in front of a variable if there isn't one? And that's 1. So A here is equal to 1. B is the one that's attached to the x, so B is equal to negative 10, and C is equal to 24. Okay, so what I want you guys to do is pause me here, and I want you guys to, on your own, plug this into the quadratic formula. So pause it and plug it in and see when you guys come back if you got the same thing. Okay, so I plugged it into the quadratic formula, the opposite of negative 10. The opposite of a negative becomes a positive. So I usually just write it as a positive. I ignore that, like that extra step completely. And then negative 10 squared minus 4 times A times C, all divided by 2A. So I'm going to go in and simplify the inside first. So this is going to be 10 plus or minus the square root. Now negative 10 squared. Negative 10 times negative 10 is positive 100. So that's why if you guys do that in your calculator, you need to also put that in parentheses too. Negative 10 squared gets you positive 100, because if you don't put it in parentheses, it will give you the negative 100, and then you'll have something wrong. And then so minus 4 times 24, which is 96, divided by 2 times 1, which is 2. Now I can simplify the inside. 100 minus 46 is 4. and divided by 2. Well, do we know what the square root of 4 is? We do. It's 10 plus or minus 2 over 2. And so now I can split it into my two solutions. So x equals 10 plus 2 over 2, and x equals 10 minus 2 over 2. Well, 10 plus 2 is 12, and 12 divided by 2 is 6. And then 10 minus 2 is 8, and 8 divided by 2 is 4. So I have my two solutions, 6 and 4. It doesn't matter what order you put these in. You could have put 4, 6, 6, 4. Do not put parentheses around it because that's signaling to me that it's an ordered pair. This is not an ordered pair. This is two ordered pairs, 6, 0, 4, 0. Now, again, because I got whole numbers and I didn't get anything with a radical, this one is actually factorable too. So if I go back to kind of here, again, when it's set equal to 0, I can factor that. So what two numbers multiply together to get me positive 24 and add to get me negative 10? It's negative 6 and negative 4. I can use the shortcut here. I don't have to split the middle term because a is equal to 1. And then now I can set each factor equal to 0. Add 6, and I get x is equal to 6. Add 4, and I get x is equal to 4. So same quadratic, different methods. I get the same thing. Doesn't matter. If you can factor it, like I said, I prefer factoring. But if you prefer quadratic formula, then do the quadratic formula. You should get to the same exact spot. Okay, so we are going to continue on with number 3. So number 3, what I want you guys to do is go through and do the first step and then identify A, B, and C. So do the first step and then identify A, B, and C. So your first step here should have been just moving the 3 to the other side of the equation. You always want it so your quadratic is set equal to 0. And then now we can identify A, B, and C. So A is the number in front of the x squared. There's just a negative, so A is going to be equal to negative 1. B is the number in front of the x, so B is equal to 7. And then C is the constant. It's the number that doesn't have a variable attached to it. And so now I can just plug that into my quadratic formula. So x equals the opposite of 7, so negative 7, plus or minus the square root of 7 squared minus 4 times A times C all over 2A. So I just plugged everything in, and then I start to simplify. So 7 squared is the first thing I would simplify. That we know is 49 minus 4 times negative 1 times negative 3. 4 times negative 1 is negative 4. Negative 4 times negative 3 is positive 12. So it becomes 49 minus 12. Divided by 2 times negative 1, which is negative 2. Okay, I'm going to simplify the inside, 49 minus 12, and that gets me 37. Okay, so now I'm at a point where I think, can I simplify that square root? Can I simplify the square root of 37? So for one, 37 is not a perfect square root, so it's not like 1 or 2 where we can simplify it like that. Then I think, well, what about, can I break it down? Is there a number that goes evenly into 37 that it's a perfect square? And there isn't. 37 is actually a prime number. So my final answer is just that. This is exactly how I would write it. X equals negative 7 plus or minus rad 37 divided by, I forgot the negative 2, because that negative 2 is in the bottom. And that would be it. Now, if you wanted to write that as an ordered pair, you could, because this is two solutions. So that would be -7 plus rad 37 over -2, 0 is one of my ordered pairs. And then -7 minus rad 37 over -2 is another one of my ordered pairs. So these are the solutions written as ordered pairs. And again, like I could get these as decimals, and the decimals would help me to graph these. But because we're not graphing, I want the exact answers. And the exact answers are going to have the square root in it. So that's your final answer. Okay, so what I want you guys to do is I want you guys to look at 4. I will tell you the first step is done for you. So what I want you guys to do is just pause me here and think about what's A, what's B, and what's C. Okay, so I got A is equal to 1, B is equal to 2, C is equal to -7. 1, 2, -7. Now what I want you guys to do is pause here, and then I want you guys to plug it into the quadratic formula on your own. So plug everything into the quadratic formula. Okay, so I plugged it in. It's the opposite of 2 plus or minus the square root of 2 squared minus 4 times A times C all over 2A. And then I simplify. So I simplify the inside. Actually, I take it back. I want you guys to pause me here, and I want you guys to go through the process and simplify it as much as you can on your own. So pause me here, try this on your own, and then come back and check your work. Okay, so I got here, I simplified the inside, 4 minus a -28, which became that plus, and then I simplified the 32. Now, this is the same point as over here. I think, can I simplify the square root of 32? 32 is not a perfect square root, but I think, is there a perfect square that goes evenly into 32? And there is. We know 32 is 16 times 2. Now, 16 times 2, or we know the square root of 16. 16, the square root of 16 is 4. And then 2 is going to stay inside. So we have x equals -2 plus or minus the 16. That 4 is going to come out. The rad 2 is going to stay inside. And then the 2 is going to stay inside. Now, what's something that's really important is we can actually go one step further. If you notice, the -2, the 4, and the 2 are all divisible by the same number. They're all divisible by 2. And if you can simplify all 3, then you can simplify this answer. Now, we don't worry about what's inside the radical, because remember, you can only simplify outside with outside. You can't simplify outside the radical with inside the radical. So -2, these are all divisible by 2. -2 divided by 2 is -1. 4 divided by 2 is 2. 2 divided by 2 is 1. So the way that I would write that is -1 plus or minus 2 rad 2. And we don't have to put it over 1. That's unnecessary. So this would be my final answer. So you can only simplify when all 3 terms outside of the radical are divisible by the same number. So this 2, 4, and 2 were all divisible by the same number. But if it was just the 2 and the 2, you wouldn't be able to simplify it. It has to be all 3. Okay, we have 2 more, and then we're going to be done. So let's keep moving. Okay, so for number 5, everything's set equal to 0. So what I want you guys to do is figure out what's A, B, and C, and then plug that into the quadratic formula. So figure out A, B, and C, plug that into the quadratic formula. So pause me here and then come back. Okay, so I identified my A as 4, B as negative 12. Oh, there's a typo in this. I didn't even recognize that. That should be 12x. I'm going to fix it on your guys' notes. So you won't even see this typo. So negative 12 is my B term and C is my 9. And then I plug it in. So opposite of negative 12 is positive 12. Negative 12 squared minus 4 times A times C all over 2A. And then I simplify. So negative 12 squared is 144 minus 4 times 4, 4 times 4 times 9 is also 144 divided by 8. Well, what is 144 minus 144? Well, that's 0. And then what's the square root of 0? Well, the square root of 0 is still 0. 12 plus 0 is 12. 12 minus 0 is 12. So really my answer is just 12 over 8. Now, can I simplify that? And I can. 12 and 8 are both divisible by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So my final answer here is 3/2. So something that's super, super important, when there is a 0 under the square root, there will only be one solution. So when there is a 0 under the square root, there will be one solution. Because plus 0 gets you the same thing as minus 0, so there's no two options there. There's not that plus it and a minus it. And that's it for 5. Okay, last one. What I want you guys to do for 6, I want you guys to identify A, B, and C, plug it into the quadratic formula, and then come back and check your work. Okay, so I got A as 2, B as 5, C as 4. So A is next to the x squared, B is next to the x, 4 is, or the C is by itself. So the opposite of 5, negative 5, plus or minus 5 squared minus 4A, C, all over 2A. And then I simplify. So 5 squared is 25 minus 4 times 2 times 4, which is 32, all over 4. Well, 25 minus 32, what happens? Well, I get a negative. And if you guys remember from the last video, what happens when there's a negative inside the square root? We can't take the square root of a negative, so what that means is no solution. Which means that the parabola doesn't ever cross the x-axis. So just like this one, when there's a 0 under the square root, there will be one solution. When there is a negative, inside the square root, there will be no solutions. So those are kind of your like two different ones there. When you have a 0 or a negative, gets you 1, and then it also gets you none. So that's it for today. That is our last method of solving a quadratic. If you guys have any questions, I encourage you guys to come to office hours, email me, whatever you guys need. I'm happy to help you in any way. So I hope you guys are doing really well. And I hope you guys have a great day. Okay, I will talk to you soon.